Hello. Okay, so hello everyone again. This is lecture number 3 on the chapter motion in a plane. So in the previous discussion, we were on the ending of understanding the concept when we understood that, let us say, a vector can be analyzed. Let us say we can find out the direction of the vector and its angle. So basically, there are two different configurations. One is if we know the value of a and theta, and another can be the resolved vector, that is ax and ay. So let's move with the further discussion in that topic only. So let's start with the lecture number 3. I'm Samir Lawankar. Let's begin our discussion. Fine. So first of all, a course outline for you. So the course outline right now, we're on the 5th topic. So only a bit of information is required to convey to you about the 5th topic. And then we can move on to the 6th topic, that is vector addition and analytical method. Fine. So introduction first of all was done, in which we understood basically, as in after motion in a straight line, what all things have to be added up. So basically we increased one dimension, in which we understood as in what happens when there is an increase in the dimension. So now, before that, when we were studying the chapter motion in a straight line, in that what was happening was only and only the direction of the velocity, displacement, etc., can be conveyed by using what we can say plus and minus sign. But this time what is happening is that we now require greater detail or greater attention to the concept of vector, and hence we studied all these concepts, in which we understood that how vector is being propagated, how is vector being calculated, etc. Fine. Then the next thing, that is scalars and vectors. In this we understood as in how what is the basic difference between a scalar and a vector. So just revising this again. So what is basically scalar? Scalar are those quantities which only has a magnitude. And what are vectors basically? Vectors are those quantities which have a magnitude and a direction. Correct? So an example of a scalar can be, let's say, path length, or let's say time, or let's say temperature. Similarly, what are the examples of your vectors? Vectors can be the example of vectors can be displacement, then velocity, acceleration, force. Correct? So these all things can be your examples of your vectors. Fine. Then we understood some of the properties of vectors only. Finally, one of the properties which was also a subtopic, that is multiplication of vectors by a real number, is being understood. And finally, we went on to understand the addition and subtraction of vectors by graphical method. Okay. So subtraction is nothing but new. That is, we just added a, and plus we added minus. Correct. So that was how we understood these all. Also, just I need to add one more thing. The different types of vectors. So the different types of vectors which we know till now is, first of all, we started with the position vector. We understood what is a position vector. Okay, so basically a vector which can be used to calculate the distance, or basically to know the position of a particular object, is a position vector. So a vector which is directed from the origin to that location is basically called a position vector. Like we denote this by r. Similarly, next thing which we understood was a displacement vector. The next thing which we understood was a displacement vector. In displacement vector, let us say that this location of P was changed to a new location called P dash. Then this vector, that is from P to P dash, is nothing but a displacement vector. Fine. And the next thing which we understood was your zero vector. So let us say that what is zero vector basically? A zero vector is a vector whose magnitude is 0, but it has a direction, but the direction cannot be specified. I also put forward this explanation in front of you also. So let me just rub this. So I also put the information in front of you also, that there's a difference between direction not specified and direction not available, or let's say no direction. Okay, so there's a difference between that. So because a zero vector has a magnitude plus it has a direction which is not specified, and hence this comes under the quantity of vector. Okay, and the fourth point was basically a unit vector. Okay, so unit vector was basically used so when we were understanding the fifth topic, that is resolution of vectors only. Basically, in this, the first concept which we understood was any vector A, let us say it is in plane, can be written as equal to lambda mu plus, sorry, not lambda mu. So it can be written as equal to nothing but lambda into A plus mu times into B. Okay, so A is a vector, small a is also a vector, B is also a vector. Okay, to make the calculations easier, to make the configurations easier, what we did was we changed it into unit vector. So basically we used, at the place of A bar we used I cap, in the place of B bar we used J cap. So these were nothing but your unit vectors. What is the definition of a unit vector? A unit vector is a vector whose magnitude is 1, whose magnitude is 1, right, and has a direction and has a direction according to the situation given. Okay, so here these are nothing but I is denoted towards x direction and j is denoted towards y direction. Okay, so this is the direction of I cap and this is the direction of j cap. Okay, so that all being said, let us now move on to the further discussion on resolution of vectors, and then we can move on to the new concept, that is vector addition analytical method. Okay, so let's move on. Fine. So in resolution of vectors, these all things that I completed in the previous discussion only. Finally, we were understanding these all topics in which we understood. Okay, so there can be two ways for to confine or specify a vector. The first is that if its magnitude A, the direction theta is given, which it makes with the x-axis, and second thing is its components ax and ay. Okay, so then the explanation was given, as in if a and theta are given, what can be done? So ax and ay can be directly obtained. So how can we obtain it? So basically ax is nothing but equal to a cos theta, and similarly ay is nothing but equal to a sin theta. Correct? Now if the thing is reversed, what is the thing reversed? So let's say if we have the value of ax and ay, then how can a and theta can be obtained? So a is nothing but equal to ax square plus ay square whole under root. Correct? Similarly, how can we obtain theta? This theta is nothing but equal to tan inverse ay by ax. Fine. So this is how you can obtain theta also, and this is how you can obtain ax. Okay, so either of the things can be done. So it depends upon whatever is given to in the question. So let's say a and theta are given, then ax and ay can be found out if the question is asked. And similarly, if ax and ay are given, and then a and theta can be calculated as follows. Fine. Then we also understood that if we can increase it to a three-dimensional axis also. So this is one of the example, as in all these vectors or all these resolved vectors of A are basically inclined at some different angles. Let's say AX, AY, and AZ. Okay, so this is basically your alpha, this is basically your beta, and this is basically your gamma. Fine. So what can be understood from here? So what we can say is ax is nothing but equal to a cos alpha, ay is nothing but equal to a cos beta, and az is nothing but equal to a cos gamma. Fine. What are these alpha, beta, and gamma here? This alpha, beta, and gamma are nothing but these angles. Fine. So this was the complete revision of the previous class. Let us now start with the new discussion today. Okay. So in general now, as in the previous discussion, when we were talking about two dimensions, then we understood that vector A is nothing but equal to, if we resolve it into two vectors, then it is equal to ax I cap plus ay j cap. It is equal to your ax I cap plus ay j cap. Okay. Similarly, for three dimensions, what we can say, that this vector a bar would be made up of what? It would be made up of three different unit vectors, correct? So those unit vectors would be what? This would be an addition of something with I, something with j, and something with k. Correct? So what we can say that three components can be? We can say that three components can be denoted as ax, AY and AZ. That is the only explanation which is given. Okay, so what we just did, we just increased our dimension from 2 to 3. So this is only and only valid, or this is only and only provided if you is only and only to be done when we are talking about 3 dimensions. Okay. So therefore, in general, so that this is the maximum dimension which can be obtained. This basically this is I, J, and K. Okay, so that is how you can represent a vector in graphical form. Okay, talking about the magnitude here. So if the magnitude is being asked, then magnitude will be nothing but equal to, let's say first we recapitulate it for the 2D dimensions. So for 2D dimensions, we know that the dimension of so the magnitude of vector A is nothing but equal to under root of ax square plus ay square. Correct? Similarly, so this was for 2 dimensions. So this was for your 2 dimensions. Similarly, for 3 dimensions, this vector A. Okay, so as it is magnitude we talked about, we won't add a bar sign here. So this will be nothing but equal to, again it will be a square root, but this time square root will involve 3 different quantities. So it will be square ax square plus ay square plus az square. So that is the only difference between the magnitude in 2 dimensions and the magnitude in 3 dimensions. Okay, so that is only being written here. Okay, that is A is nothing but equal to under root of ax square plus ay square plus az. Okay, so these are in subscripts only. Okay, so these are in subscripts. So it's only, so just a representation that we are saying that this is the information or the value of the magnitude which is in the x direction. Okay, so that being said, let me just devise it also here. So what is actually happening? Please look at this figure very carefully so that we can understand what is actually happening here. So as you can see, this was the actual vector A. Correct? Now it was being resolved. So let me rewrite also. So A vector is resolved into 3 components. Namely ax in x direction, ay in y direction, and az in z direction. Okay, so that is how these things are done. So as you can see, this is the x direction in which we have resolved the vector which is called as ax. Ax is also written here if you can see it clearly. Similarly, in the y direction you can see that this is the resolved vector. Okay, so this is the resolved vector here, and similarly you can see in the z direction that this is the resolved vector here. Okay, so the names are also provided. So this will be your az, and similarly this will be your ay. Okay, so if you know the value of ax, ay, and az, we can calculate the value of capital A, the magnitude of capital A. How? We can calculate it like this, that A is nothing but equal to under root of ax square plus ay square plus az. Fine. Similarly, if we know the values of ax, ay, and az, and let us say we also know the value of A, then we can calculate these inclinations also. Okay, here so in 2D axis there will be only one inclination which can be denoted by angle theta, but in 3 axis there will be 3 different inclinations. More information about these inclinations will be explained to you when you will understand the chapter, that is 3D geometry, in your mathematics classes. Okay, so let's not go into that. Just I'm explaining you. Let us say we know the value of x. So this is given. Let us suppose. So let us say we know the value of ax, ay, az, and a. Correct? And what we can do? We know that ax is nothing but equal to a cos alpha. We also know ay is also equal to a cos beta, and az is equal to a cos gamma. Correct? Therefore, from this we can say what is cos alpha. Cos alpha is nothing but equal to ax upon a. Similarly, what is cos beta? Cos beta is equal to ay upon a. Similarly, what is cos gamma? Cos gamma is nothing but equal to az upon a. Correct? So from here we can obtain the value of all these angles. Okay. So let me do for one. So it is nothing but alpha, which is equal to cos inverse. So this is called as cos inverse ax upon a. Fine. So that is how you can obtain the values of alpha, beta, and gamma. Okay. So that was the only explanation which was given. That this is how the vectors are being resolved for 3D coordinates. Fine. So let's move on with our next expression here. So what is written here? So I think I have explained this clearly to you. Okay. So now next thing says that a position vector R. So if you remember correctly, we have understood 4 different concepts. The first vector which we understood was position vector. Correct? So for position vector, what do we understand? Let me revise to you. So let us say we are only talking about 2 dimensions. Correct? So for 2 dimensions, this is your x-axis, this is your y-axis. Okay? Let us say that at some point, at some time t, the value of the object was at position p. Therefore, what we can say that if a vector is being drawn with the tail at O and head at P, then that is called as your position vector. Okay, so that is called as a position vector. Let me denote this vector by R bar. Okay. So therefore, what we can say, let us say this P will have some coordinates. That coordinates will be, let's say, x dash and y dash. Okay, how to calculate those coordinates? Just draw perpendiculars like this and similarly like this. So you can obtain the point which is x dash here, and similarly you can obtain the point which is y dash here. Right? Now, from the concept of unit vectors, we know that along the x-axis we have the unit vector which is called as I cap. Along the y vector we have along the y direction we have the unit vector j cap. Okay, so now let us say we have to resolve the position vector R. How will we resolve this? We will say that the vector R is a summation of 2 different quantities. Correct? That is some I cap and some j cap. Now there will be some quantity which is written here. Okay, so how can we find out those quantities? Those quantities are nothing but the resolution of this length, along x-axis and along y-axis. It is quite clear from the figure that along x-axis, what will be the length? This will be the length. Correct? That will be your x component. So this thing is also explained here also. Let us suppose that this A is nothing but your position vector only. Therefore, what will be this ax value? This ax will be in this case scenario equal to x dash. Correct? Similarly, what will be the y length scenario here? Y will be equal to y dash. Okay. So hope I made it clear to you. Therefore, what we can write? We can write that this position vector R, which is a vector, is equal to 2 different vectors. Okay. So I and j cap are vectors only. Similarly, we can write this as equal to some x dash I cap plus y dash j cap. Okay, so that is how we understand this situation using your 2D plane or 2 dimensions. Let us now increase it to a 3-dimensional expression. Okay, so what would be happening? Let us try to understand this with this diagram here. So as we can see that in this figure D, this was a complete vector. Right? This was resolved into 3 components. These 3 components were ax, ay, and az. Okay. What was the values of this x, y, and z? Those were nothing but, so basically depending on, let us say that this vector A is nothing but the position vector of the object which is kept at this location. Correct? Then the coordinates of this location would be what? It will be equal to x, y, z. I am assuming this to be x, y, z. Okay, so let us start writing this. So what will be position vector R? That position vector R bar will be nothing but summation of three different quantities, because we are calculating it in three dimension. That will be equal to some I cap plus j cap plus k cap. Correct? What are these I cap, j cap and k cap? These are nothing but your unit vectors. Correct? So these are nothing but your unit vectors. Okay, so this is nothing but your unit vectors. Okay, so therefore what we will say that if it's a position vector, let we did likewise we did for two dimension. So what we did for two dimensional thing, so for two dimension what we said that this r bar is nothing but equal to x I cap plus y j cap. Okay, so similarly what we will do here, we will also do that x I cap plus y j cap plus z k cap. So that will be the position vector along three-dimensional space, which is also written here. Okay, so let me just iterate this and then we can move forward. So this thing is explained, this thing is explained. So now a position vector r bar can be expressed as, how it can be expressed? This is nothing but equal to r bar, which is equal to x I cap plus y j cap plus z k cap, where x, y and z are the components of R. What are those? They are components of R along the x, y and z axis respectively. Okay, so that was the explanation of a position vector. Just let me revise one more thing and then we can move forward. Please remember that here R bar, x I cap, y j cap, z k cap, all these are vectors. Okay, also remember I cap, j cap and k cap, these all are vectors only. Okay, so or if we say in more detailing, we can say that these are nothing but your unit vectors. Okay, so it is just a revision so that we can get informed with the concepts here. But x, y and z, these are nothing but your scalars. So if we just write x, y and z, those are nothing but your scalars. Okay, so these just contain magnitude values. Okay, so this does not, these are not encompassing under the scalar concept, under the vector concept. They're encompassing under the scalar concept only. If we add x I cap, if we say it is x I cap, then this can be said as a vector. This can be said as a vector, but this cannot be said as a vector. Okay, so that was as a general information to be provided. I will try to provide it again and again so that this vector concept is clear. Okay, so that being said, we have understood clearly how we resolve the vectors and how we understand the vectors in three dimensions also. Okay, fine. So that being said, now let us move on to the new subtopic, which is vector addition by analytical method. Okay, so in the all previous discussions till now, what we did was we understood each and every concept using graphical method. Correct. So what we basically did was we had some vector A, let's say denoted in this direction. We had some vector B, let us suppose in this direction. So what we basically did, let us say this is that vector A, let us say this is that vector B. If we need to add both of them, we will add it like this. Correct. So this will be nothing but a resultant, which is equal to A plus B. Okay. But let us say, what if I give you 10 different vectors like this? What if I give you 10 different vectors like this, which are, let's say, in this direction, something in this, something in this, something in this, something in this. So you cannot just make a graph and keep on adding everything. It will be cumbersome also, and it will take time also. So to reduce that time and to make the complete information using mathematical formulation, we will go to understand this concept, which is vector addition by analytical method. Okay, so let us start this and then we can increase our understanding and comparison between graphical and analytical method as we move on. Okay, so let's start understanding vector addition clearly. Okay, so although the graphical method of adding vectors helps us in visualizing the vectors, so we can visualize the vectors very clearly and the resultant vector also, but it is sometimes tedious and has limited accuracy. Okay, sometimes accuracy cannot be calculated. Let us suppose, just to understand what is meant by accuracy here. So let us say we had two vectors. Okay, we had a vector in this direction. We had some vector in this direction. Okay, so let us say we had a graph with some specifications. So it was 1, 2, 3, 4. Let us suppose, and similar this was also 1, 2, 3. Okay. Now let us say that this was 4.9 units. Okay, and this was, let us suppose, equal to I am just telling about the magnitude. Okay, so this magnitude was nothing but 3.7 units, let us suppose, and this angle was given to you as in the question as 33.42. Okay, so because of these decimal propagations happening here, when you will try to find out the value of resultant, there will be a error. Let's say if I try to use we will use visually, will give the answer visually only. So what if this value of resultant R came out to be, let us suppose I don't know the exact answer, but let us suppose it came out to be 7.9 visually. But what if the answer is let's say 791? Okay, that is the correct answer. That is a true answer. But because of the visual answer, the answer came out to be 7.9. So that will lead to very greater errors if we need to add vectors which are more than 2. Okay, so to decrease this errors, to increase the accuracy, what we basically do is we try to do vector addition by using analytical method. Okay, so I hope this thing is clear, as in why we needed all this new concept, this analytical concept. Now let us start understanding this concept. Okay, so although the graphical method of adding vectors helps us in visualizing the vectors and the resultant vector, it is sometimes tedious and has limited accuracy. It is much easier to add vectors by combining their respective components. Okay, so what is this explanation being done here? What they're saying is, first of all, let me iterate and then I can explain you again. Okay, so first of all, let us consider two different vectors in the xy plane with components ax, ay, bx and by. Okay, so A is having components as ax and ay. So what does this ax and ay tell you? So basically resolving of vectors is being done. Resolving of vectors. Okay, so so as it is subscript x is given, so therefore this will be in the x direction, and y is given, therefore this will be done in y direction. Right? Now next thing is that similarly what we also did for b. Okay, so it was basically your bx and this was your by. So it was in x direction and this was also this was in y direction. Okay, just to explain what is happening, actually let us say I put one of the vectors in xy in graphical form. So what is basically happening, let us say this is x and y. Let us say this is that vector a being talked about. So how we will calculate the value of components of vector a? We will just drop perpendicular from here. Similarly, we will draw perpendicular from here, the point at which it locates. So this is basically ax, and the point at which this will locate. So this is the length, which is ay. Okay, so that is how we can understand ax and ay. Similarly, we can do the similar thing for b also. Okay, that being said, now how to represent it? We have understood the representation also in just the previous example, that we can represent, let's say we need to represent a. So how we will represent it? It will be summation of two different vectors. That is, let's say it is I cap and j cap. What will be the magnitude here? It will be ax. What will be the magnitude here? It will be ay. Okay. Similarly, for b vector, so b vector will have a magnitude again which will be addition of two different vectors, that is I cap and j cap. So on this place we will write bx, on this place we will write by. Correct? Because I cap is in x direction, so we can write the magnitude as equal to bx. Similarly, y cap is in y direction, so we can write it as by. Right? That being said, so we understood these two equations correctly. Now let us move on to the next equation. So now let R be their sum. If R be their sum, then we can write R is nothing but equal to a plus b. I think there is nothing wrong in this situation here. Now what they wrote this as equal to ax plus ay plus bxi plus byj. Okay, so what they just did R is nothing but equal to a plus b. Vector formation, everything is just vector only. So now using this equation number 1 and this equation number 2. What we can write? We can write this r vector is nothing but equal to ax I cap plus ay j cap plus bx I cap plus by j cap. Okay. Now let us read the next line. Now, since vectors obey the commutative and the associative laws, so just to revise you, what are these commutative and associative laws? These laws just states that the vectors a plus b is equal to b plus a. And next law states that a plus b plus c is equal to a plus b plus c. Okay. Fine. So we can arrange and regroup the vectors in the above equation as convenient to us. Okay. So this is how we added, or basically we regrouped the vectors. Okay. So how was the regrouping done? I will explain to you. So how was the regrouping done? As you can see clearly here, this was also in I direction and this was also in I direction. Correct. So these two can be regrouped. And it can be written as nothing but ax I cap plus bx I cap. Correct. Similarly, what we can say that this both can be regrouped and it can be written as ay j cap plus by j cap. Okay. Now let us look at one situation. So what does it mean? So that in this direction, let us say ax I cap was working upon. In the same direction, bx I cap was also working upon. Correct? So they had some magnitude, they had some direction. It is quite clear that if we add both of these vectors, then the resultant vector only which can be calculated from this will have the direction which is same. Correct? Because the direction is same, what we can do, we can just add the magnitudes of these both vectors and we will get the magnitude of this new vector. Let us say I denote it by some p cap. Okay. So it is quite evident because the direction of both of them are in the same direction, we can directly add them. And because we can directly add them, it is quite clear that because the direction is same, the length will be same. So the length will be, not the length will be same, the length will be added up directly by using algebraic operations. So therefore we can write this as equal to nothing but ax plus bx. This is only and only valid because we are directing our vectors in the same direction. Okay. Similarly, we can understand the same situation for this also. So what is happening here? So there was some ay which was acting in this direction, ay j cap which was acting in this direction. Similarly, there was some by j cap also which was acting in this direction. Okay. Therefore, we can just add them directly, and if we add them directly, it is quite evident that the new vector which is formed, let's say divided by q dash, will have the same direction, and we can write that this has a magnitude which is equal to ay plus by, and because it is in j direction only, we can write this as equal to ay plus by whole times j cap. Okay. So that thing being said, so this is equal to this plus this, and therefore we can write this as equal to ax plus bx I cap plus ay plus by j cap. Clear? Fine. So that is the only thing which is being written. Okay, so that is the only thing written here. That is r is nothing but equal to ax plus bx I cap plus ay plus by j cap. Fine. Since r is nothing but equal to rx I cap plus ry j cap. Okay, so how is this thing obtained? We have understood this in the previous discussion also. Let me just go back and explain to you. So, okay, we can understand from this portion only. Okay, so let us remove the k cap portion. Then any vector will be nothing but the summation of ax I cap and ay j cap. So in the similar form, we can write this as nothing but r bar is also equal to rx I cap plus ry j cap. Okay, so r bar is also equal to rx I cap plus ry j cap. Okay, so now using or by just viewing these two equations, what we can write? We can write that rx is nothing but equal to ax plus bx, and similarly ry is nothing but equal to ay plus by. Clear? Nothing. I'm just observing these two equations. I'm just observing these two equations and trying to find out what is rx and ry equal to, right? So therefore we have rx is equal to ax plus bx, and similarly ry is equal to ay plus by. That being said, thus each component of the resultant vector r. What are the components of the resultant vector r? This is one of the component of resultant vector r, and similarly this is the component of the resultant vector r. Okay. So this is one of the component and this is one of the component. Okay. So that being said, thus each component of the resultant vector r is the sum of corresponding components of ax and b. So that the mathematical form is just written in the theoretical form. Okay. That is the resultant vector. Each component of a resultant vector r is the sum of the corresponding components of a and b. Okay. Again, we can say that each component of resultant vector r is nothing but the sum of the corresponding components of a and b. Fine. That being said, let's move on. Okay, so now understand more clearly. Okay, now I'll just broaden our aspect and let us move on to 3 dimensions here. Okay, so what happens in 3 dimensions here? So in 3 dimensions, we have understood in the starting of this lecture series only, lecture only, that what is A? A can be written as equal to AXI cap plus B, not, just give me, okay, AXI cap plus AYJ cap plus AZK cap, right? Similarly, we can write this for B also. So what will be B? B will be equal to BXI cap plus BYJ cap plus BZK cap. Okay. Now, if you need to calculate the value of R, what will be this value of R, which is equal to A plus B? So in the previous discussion only, what was the thing which we concluded? That each component, what we concluded is that each component of the resultant vector R is nothing but the corresponding components of A and B. Okay. So we will just add all the components which are in X direction. We will just add all the components which are in Y direction. We will just add all the components in the Z direction. Therefore, we can write that Rx is nothing but equal to Ax plus Bx. Ry is nothing but equal to Ay plus By. And Rz is nothing but equal to Az plus Bz. Clear? That is the only thing which is written. Okay. So because we have understood this for 2 dimension, it is quite clear to understand this for 3 dimension also. Okay. What is the meaning of the word dimension here? So basically 1 dimension refers to your x axis, 2 dimension refers to your x and y axis, or let's say y and z axis, or let's say z and x axis, and 3 dimension refers to your x, y, z axis. So 1 dimension refers to x, y, z, x or y or z. Similarly, 2 remains to x, y or y, z or z, x, and 3 refers to x, y, and z. Fine. I've explained you this thing. Let's move on. So this method can be extended to addition and subtraction of any number of vectors. Okay. So till this explanation here, we were adding 2 vectors. Okay. So now let us increase the number of vectors and let us add 3 dimensions here. Sorry, not 3 dimensions. Sorry, we will add 3 vectors here. Let us add 3 vectors here. Okay, so let me just rub. Okay, so this method can be extended to addition and subtraction of any number of vectors. For example, let's say we need to add the vectors which are A, B, and C. First of all, let us write A, B, and C so that we can have a habit of understanding everything. What can the vector A can be written into? It can be written into some I cap, some j cap, and some k cap. Correct? What will be the magnitude inside along the x-axis? It can be denoted as equal to ax. Similarly, this can be denoted as ay. This can be denoted as az. We can do the same for the b also. So it's bx I cap plus by j cap plus bz k cap. Similarly, for C bar, we can write this as equal to Cxi cap plus Cyj cap plus Cz k cap. Fine. Now what we need to do, let us say we need to add or make a vector which is t is equal to a plus b minus c. Okay, don't look at the complexity of this, just remember this final rule. If you remember this final rule, everything will be clear. Each component of the resultant vector is the sum of the corresponding components of a, b, and this, in this case it will be c also. Okay, so what we will do, we need to find out some vector t. So this vector t can be denoted as nothing but some tx I cap, some ty j cap, some tz k cap. Correct? It is given in the question, or it is given in the discussion, that t bar is nothing but equal to a plus b minus c. Okay, so these, everything is written here is in bold because I cannot write again and again in bold. That's why I'm using the denotation of bar here. Okay, therefore we will just, what we will do, we will just add the components of a, b and minus c. Please remember it is minus c here. Okay, therefore what we will write, we will write tx is nothing but ax plus bx minus cx. What will be ty? Ay plus by minus cy. Similarly, what is tz? It is az plus bz minus cz. Correct? So that is the only thing which is written. Okay, thus a vector t which is equal to a plus b minus c has components, that is tx is equal to ax plus bx minus cx. Similarly, ty is equal to ay plus by minus cy, and tz which is equal to az plus bz minus cz. Okay, let's move on then. Okay, so now let us try to understand this example first and then we can move forward. Okay, so this example I think can be understood right now for you. So let us start this example once. Okay, so let's understand. So rain is falling vertically with a speed of 35 meter per second. Okay, so what is the general formation or direction of rain here? So rain, we know that it falls vertically, right? This, right? So it is given that is falling vertically at a speed of 35 meter per second. So let us denote the velocity of rain by VR, okay, which is given to us as 35 meter per second. Okay, wind starts blowing after some time with a speed of 12 meter per second in east to west direction. Okay, so please remember, so we know that top is north, below is south, left is your west, and right is your east. So what is the direction of wind given to you in the question? It is given as east to west. So this will be the direction of your wind. Okay, so let us make the wind also. So this is the wind. How can you denote wind? We can denote it as VW. The magnitude of VW is given to you as 12 meter per second. Okay. In which direction should a boy waiting at a bus stop hold his umbrella? Okay, so basically we need to so the boy just needs, so that he doesn't get wet, so he has to put an umbrella top of him. Okay, so how he should keep his umbrella, at which angle, so that he doesn't get wet? That is the question being asked here. Okay, so rain would be falling like this. He just want that because of the accumulation of this force or vector velocity due to the rain and wind, he doesn't get wet. Okay, let us understand this carefully here. So the resultant rain would be followed at an angle which will be summation of your VR and VW here. Okay, so just first read the solution. So the velocity of the rain and the wind are represented by the vectors VR and VW in the figure and in the direction specified by the problem. Okay, so similar thing has been drawn here. As you can see, that this will be VR in the vertical direction and this will be VW from east to west direction. Therefore, what is the direction in which we can get the resultant? So this will be the direction of the resultant. Correct? Now it is quite clear. Now it is quite clear from this situation here that this R vector can be written as equal to, let us say this is your I direction. Correct? So let us say this is your I cap direction and this is your j cap direction. Correct? So what we can write, R vector is nothing but equal to your Rx I cap plus Ry j cap. Correct? So therefore what we can say, that this Rx is nothing but equal to minus 12 because I cap is in positive direction and we are moving in the left hand side. Similarly, what is Ry? Ry will be equal to minus 35. Okay, this is meter per second, this is meter per second. Okay, now what we need, we just need to calculate the value of R. Okay, so we have understood this concept also, that if we know the value of Rx and Ry, how can we calculate the value of R? This R can be calculated as nothing but equal to under root of Rx square plus Ry square. Correct? So let us calculate that. So this will be nothing but equal to your 12 square plus 35 square. So if you calculate this, you will get the answer as nothing but 37 meter per second. Fine. So we calculated the value of resultant. Now let us calculate the angle at which this would happen. Let us say that this is the angle at which the resultant is from the VR position. Okay. So if I just make this triangle completely, if I make this triangle completely, let's say this is that angle theta, this is that vector r bar. Okay, this is the velocity VR, and this can be said as VW. Correct? So this VW just can be put forward here also, right? This is a triangle being formed. Now using simple mathematical trigonometry, what we can find? What is this tan theta? Tan theta is nothing but equal to this upon this. So then this can be written as nothing but VW upon VR. Correct? So VW is given to you, the magnitude of VW is given to you as 12, and the magnitude of VR is given to you as 35. Correct? So therefore what we can find, that theta is nothing but equal to tan inverse of 12 upon 35, which is equal to 90 degrees. Fine. So what is the conclusion here? The conclusion is that the umbrella should be kept somewhere in this direction. So the umbrella is kept like this, the rain would be falling in this direction, and therefore the boy can be saved from getting wet. That is the only thing which is written here. Therefore the boy should hold his umbrella in the vertical plane. So this is the vertical plane, if it is clear to you. So this is the vertical plane at an angle of about 19 degrees with the vertical, at an angle of 19 degrees with the vertical, because this is an angle with the vertical, towards the east. So where do we keep it? Towards the east. So angle can be either in this form also, and angle can be in this form also. That is why we need to write this line also, that is towards the east. So where we are pointing towards, we are pointing towards the east direction. Okay, if this would have written as towards the west, then this would have been the case. But because it is written as towards the east here, what we will do? We will do it in this direction. And hence the boy can be saved from getting wet. Okay, so hope I made you clear regarding this example here. Fine. So that being said, let's move forward. Okay, now let us understand the actual analytical formulation of calculating or addition of two vectors by an example given here. Okay, so I will start this complete concept as much as possible in this lecture, and then I will revise it in the next lecture, and then we can move forward. Right? So find the magnitude and the direction of the resultant of the two vectors A and B in terms of their magnitudes and the angle theta between them. Okay, so we are taking this case into scenario as in this is the vector A. Okay, this is the vector B, and this is their resultant. So okay, so if this is the resultant R, this is the angle theta. So how can we calculate this to be a resultant R? We have understood what was the definition of vector. Vector was defined as a quantity. So vector is a quantity which has a magnitude and a direction which follows triangular or triangle law of addition, or parallelogram law of addition. Okay, so that was the definition. So because it follows parallelogram law of addition, because it follows triangular law of addition, what we can do? We can write this in this form. That is, this is, let's say this is A, let's say this is B, then we can say that the resultant is this. Okay, so that is how we can say that this is following a parallelogram law of addition. Okay, so let us understand here. So let OP and OQ represent the two vectors A and B making an angle theta as we see the figure. Okay, so this is your OP here. So this is your OP, which is vector A. So this is your OQ here, which is your vector B. Okay. Now, using the parallelogram method of vector addition, OS, OS represents the resultant vector R. Quite clear. So this can be written as R bar, which is nothing but equal to A bar plus B bar. Fine. So that has also been explained here. Next thing is that now let us so now we need to do some mathematical geometrical manipulations here, and then we can understand the result. Okay, so now what is being said here, so first of all let us make it to be a parallelogram like this and a parallelogram like this. Okay, now it is being said that let us drop a perpendicular from this position S. So if we drop a perpendicular from this position S, it would join the elongation of the vector A at some location. Let us say this location to be N. Okay, so SN is normal to OP. So this is your O, this is your P. It is quite evident it is perpendicular to OP, and PM is normal to OS. So similarly, what we did. This was the resultant vector R, and here also we made a perpendicular which was PM. So this was the perpendicular here, which was PM. So this was also perpendicular. Fine. Next thing is now for the geometry of the figure. Now using simple this formula, which is OS square. So now let's just look at the triangle. Your OS is equal to SN plus ON, right? So this is, just look at triangle OSN. Okay, so using the Pythagoras theorem, what we can say that the hypotenuse square, that is the square of this, will be nothing but equal to the ON square, which is this, plus SN square, which is this. Correct? So we just wrote that thing here. Now we know that what is ON. What is ON? Now we need to add something here. Similarly, so what is ON here? ON is nothing but equal to this OP, OP plus PN. Correct? What is the value of OP? OP we know that is angle is the magnitude is A only. And what is PN? PN is nothing but equal to B cos theta. How is B cos theta obtained? Just look at this small triangle, which is this S. This is your N, and this is your P. Correct? If this is B and this is theta, then trigonometry, simple trigonometry, this can be obtained as nothing but equal to B cos theta. And similarly, this can be obtained as nothing but equal to B sin theta. Okay, so that being said, now what we can say, in the place of ON we can write A plus B cos theta, right? Similarly, in the place of SN we can write B sin theta, right? So now after calculation, we will finally get the answer as equal to R is equal to under root A square plus B square plus 2AB cos theta. I will derive this in the next lecture, in the starting of this lecture here. Let me stop it till here only. We will start a revision from this point, and then we can finally, I will derive this as the equation which is written on the final of this slide. Okay, so R is equal to under root A square plus B square plus 2AB cos theta. Fine. So let me stop it here only. We will discuss this in the further in the next class. So just the course progress for you. We have started with the introduction, then we completed scalars and vectors, the difference between scalars and vectors, then multiplication of vectors by real numbers, then addition and subtraction of vectors by graphical method, then the resolution of vectors, and finally right now we are on the understanding of vector addition analytical method. After this is completed, we can move on to the main discussion about motion in a plane, projectile motion, relative velocity, uniform circular motion, etc. Okay, fine. So it is a topic which needs much more clarity. We'll go very slowly and understand each and every topic. Fine. So that being said, thank you for this class. We'll meet in the next class. So thank you so much.